All right. So let's talk about what an expression is. So an expression. An expression. So an expression is a collection of numbers, variables, and operations. All right, so a collection of variables, numbers, and operations. I'm sorry? You're welcome. All right, so examples of expression would be something like this. 4x. So that's an expression. It's made up of the number 4. It's made up of the number x. And what operation do you see there? Multiplication. 3x minus 4 is an expression. It's made up of the numbers 3, 4, the variable x. You have multiplication and you have subtraction. So those are examples of expressions. You can have different variables. 7x minus 2y. So that's an expression. It's made up of the variables x and y. It's made up of multiplication. It's made up of a subtraction here, and so on. Okay? So what you turn in today, now who just came in? I need the assignment. Let's do. What you turned in today, those were expressions. All of those were expressions. So I'm just using someone's here. All these are expressions. That's an expression. That's an expression. Those are all expressions. See that? All those are expressions. All right, now let's talk about terms. So one of the things you have to be able to do when combining is know what terms are and whether they're alike or not alike. So terms are separated. Terms are separated by the addition symbol. All right, so terms are separated by the addition symbol. So an example, let's look at this. So we're going to state the terms. And then here's my first expression. So let's say I'm looking at this expression. X plus 5. So we're going to start with a simple one. So x plus 5. So this expression has two terms. My terms are, and on the worksheet on my math lab, they're going to ask you to separate the terms by a comma. So the terms are x, comma, and what's the other term? 5. So those are your terms. B, 3x minus 7. 3x minus 7. Terms. I'm going to do this. Terms are, okay, the first one's easy. What's the first one? 3x. Comma. Now, what is the second one? Negative 7. Not 7, negative 7. Because remember, the subtraction you need to always rewrite as addition, just like you did last semester. So you got to remember that 3x minus 7, this right here, means the same thing as saying 3x plus the opposite. What's the opposite of 7? Negative 7. So remember, terms are separated by the addition symbol. This is subtraction. You got to change it to what? Addition. Now, once you know what we just talked about, you don't have to change it to addition. You just know that my terms are 3x, and what's the next one? Negative 7. All right, so those are your terms. All right, so 3x squared minus 5x plus 3. 3x squared minus 5x plus 3. So how many terms do I have here? 3. I have 3 terms. I have 3 terms. What are they? What's the first one? 3x squared, comma, what's the next one? Negative 5x. What's the next one? Positive 3. All right, so you now know what terms are. Okay, so let's look at this example. I'm going to look at example D. I'm going to write this. This is my expression, 4x minus 3y plus 6 minus x squared. And then on the worksheet, there are going to be some blanks. You're going to see what it's going to look like when you get it. So I'll have a bunch of blanks. All right, and in the blanks, you can list the terms. Now, there are more blanks than terms. That's right. So what would you list in the first blank?
4x.
What about the second?
Negative 3y.
What about the third?
6.
And the last one?
Negative x squared.
All right. So those are your terms. So there are 4 of them. Okay? All right. Now, let's talk about what's called the numerical coefficient. Oh, by the way, so this expression, we'll just do E for right now. This expression, how many terms do you see?
1.
1. It's still a term. There's just one term. So in the blank, you would just put what? 7x. Okay? All right. The numerical coefficient. All right. Numerical coefficient. Right there. Okay, so the numerical coefficient of a term, numerical coefficient of a term is the number you are multiplying the variable by. And so when you combine like terms, you'll be looking at coefficients. So the numerical coefficient of a term is the number you're multiplying the variable by. Sometimes it'll just be called coefficient. So numerical coefficient / coefficient mean the same thing. Okay, so let's state the coefficient. Okay, A, 6x. What goes in the blank? 6. It's whatever you multiply the variable by. I'm multiplying the variable by 6. So don't put 6x. It's the number that you're multiplying the variable by. So my numerical coefficient is just 6. B, negative 2/3, that's a 3, negative 2/3, negative 2/3 x, y. For that term, what's the numerical coefficient?
Negative 2/3.
Negative 2/3. C, x. Yes, there is.
Oh,
One.
one.
It's 1.
Because it's already understood.
Yeah.
Got it.
So there's, yes.
That's where I was getting confused at earlier when I said x equals 1 and you were saying no, it's a variable. So that's where I was
Oh, okay.
confused at.
I see.
And I just wanted to clarify.
Yeah. No, no, I understand. No, you're right. So it was a coefficient that you were thinking of.
Okay, that's what
Yeah.
I wasn't understanding.
Yeah.
Got it. Thank
Okay. All right. So remember, this right here is understood to be 1. So it's 1 times x is the same thing as x. So the numerical coefficient or the coefficient is 1. D, what if you had negative y?
-1.
Negative 1. So that's, hold on, that's negative 1y. So the numerical coefficient's negative 1. What's your question?
So with the negative 2/3 xy, wouldn't you also have a 1 as a coefficient in front of the y?
No.
No?
No. Now, if you want to look at it that way, you can say, all right, well, in this right here, the same thing as say negative 2/3 times x times 1 times y. Sure, but what's negative 2/3 times 1? Negative 2/3. Okay? So your coefficient is whatever you multiply the variable by. Now, there might be a situation where, going back to what she's talking about, what if you had this? What if you had 3 times x times 2 times y? What's the coefficient? Listen to the question. What's the coefficient? I'm going to write this as e. Put this as e. What is the coefficient of that term?
Which term?
No, right here.
1? It'd be 1.
Yeah, what's 3 times 2? 6. So isn't this term 6xy?
Yeah.
So what's the coefficient? 6. I was going back to what she was talking about. She was saying in the coefficient of y1. Well, not really, because this is already in simplified form. This was not simplified, so you just wrote it as 6xy, and the coefficient is 6. So this term right here has how many variables in it? 2. What is the coefficient of that term? 6.
Okay.
All right.
So the only time it is a understood 1 is if there's no coefficient in front of it?
That's right. All right, number or letter F, what if you had 1/3 x squared y? 1/3 x squared y.
Would it be 1/3 and then 1?
Okay, you keep saying that, girl.
Oh, sorry.
You say 1/3 and then 1. We just had a discussion about B and E. What is the coefficient of x squared y?
So I just keep separating instead of keeping it all together.
No,
So it's
you're not supposed to.
1/3 squared, which is
What is the coefficient, guys?
1/3.
1/3. It's just 1/3. Whatever you multiplying the variables by. So x squared y is being multiplied by what? 1/3. Okay? All right, y'all making it more difficult than it is. Math is not difficult.
Math is my kryptonite.
All right. All right, let's talk about, now that you know what terms are and what coefficients are and what expressions are, so let's talk about like and unlike terms. All right, so like and unlike terms. All right, so listen to what like terms are. So like and unlike terms. Okay, so like terms are terms that have the same variables, and those variables have the same corresponding exponents. So like terms are terms that have the same variables and the variables, or I should say the corresponding variables, let me change this corresponding variables have the same exponent. All right, so like terms are terms that have the same variables and those corresponding variables, you see what I'm talking about a little while with the word corresponding, have the same exponents. Okay, so this is page 607, number 10. 607, number 10. All right, so what on the worksheet, same thing. They're going to give you a pair of terms. And the directions are they like or unlike terms? Now, if they're not like terms, they're then what? Unlike terms. Okay? All right, so let's start, and this is number 10. I said A, but number 10. All right, here's number 10. You have AB cubed, so that's my first term, comma, negative 7AB cubed. So we're going to talk about that phrase we just wrote. First of all, do you think that those terms are like or unlike? They're like terms. So both terms have the variable A in it, right? Both terms have the variable B in it. All right, so what I mean by corresponding variables is that the A's corresponding, so these two A's that are corresponding, they have the same exponent. Yeah, what's the exponent? No, A, the coefficient, the exponent of A is not 3, it's 1. A to the first power. Make sure you remember that. If there's no exponent there, it's understood to be a 1. B, do they have the same exponent? Yes, it is 3. The coefficient has nothing, there's no word about coefficient in here. So it does not matter what the coefficients are. Coefficients here are different. What's this coefficient I'm pointing to? 1. What's this coefficient? Negative 7. All right. So these are like terms. Like terms are based on whether the terms having the same variables, and the corresponding variables have the same exponent. So these are like terms. Number 12. Here are my two terms, 7.4 p cubed q squared, comma, and then 7.4 p cubed q squared, 6.2 p cubed q squared r. That's an r. Right, so, okay, like or unlike? Unlike. Although they both have p's in it, and the p's are raised to the same power, and q's in it, and the q's are raised to the same power, what's the issue? R. They both don't have r. So those are unlike terms. So these are unlike terms since they both don't contain r. All right, so that's an r. So unlike terms since they both don't contain r. All right, let's look at this example. Write this example. Suppose I had 7x comma 3. 7x comma 3. Like or unlike? Unlike. One has x, the other one does not. So these are unlike terms. Since they both don't contain x. Okay? All right, now, Okay, what about this? Four thirds, comma, 2. 4/3, comma, 2.
Like,
Yeah, those are numbers. Those are numbers. You know how to add 4/3 and 2. You've added it since many, many years ago. You find the LCD and all that, right?
mhm.
All right, so those are just numbers. In fact, we're going to talk about this, but let's go ahead and say it now. Those are constants. So these are constants. So these terms are constants. These terms are called constants. Okay, constants. So you're going to hear that word quite often, constants. So constants don't have a variable attached to it. It's just a number. So no variable. All right. And you can always combine constants. And constants, all constants are like terms. So these are like terms. Like terms. Okay? All right. So you know what like terms are, and you know what unlike terms are. All right, so don't forget, these are called constants. In number 10, did we have any terms that were constants in number 10?
Yes.
Which ones? What term is a constant?
Right now.
Is it number 10?
Yeah, number 10. The one. No, those are not constants.
All we got is
Those
-7.
that's a coefficient.
Yeah, that's right.
Okay, so those are not constants. These are variable terms, by the way, because they have variables. In number 12, are any of these terms called constant terms? No, because they have what in them? Variables. In this first example we did, these two terms that I'm pointing to, are any of those terms called a constant term?
3.
Yes, 3. Okay? All right, so you need to know what constant terms are. The others, if it contains a variable, it's called a variable term.
So it's always a constant that does not have a variable attached.
That's right, no variable. Just like this, no variable.
Constants always like terms.
Yes. Yeah. You can combine constants. So variable terms contain variables. Okay. All right. Now, yes.
When you went over the X, and I think this is something y'all went over last semester apparently, because you brought it up before and it continues to confuse me. When you have a minus and you turn it into a plus, I don't understand how it just, because, I mean.
Subtraction is adding the opposite. Her question is this. 7 subtract 2 means the same thing as 7 plus a -2.
I understand it when it's like that, but when it's the way you did the problem earlier, it has a constant and a variable, I guess.
Same thing. If I have 7 subtract x, that means 7 plus a -x. Compare the two. They mean the same thing.
So I thought that you had like a minus and you just changed the minus to a plus, but you're saying you changed it.
It's
to-
called adding the opposite. So 7, a positive 7 subtract a positive 2, that's what this reads. Means the same thing as saying a positive 7 plus the opposite of a positive 2. The opposite of a positive 2 is a -2. A positive 7 subtract a positive x means the same thing as positive 7 plus the opposite of a positive x. And what's the opposite of a positive x? A -x. Okay?
Oh, okay. So you rewrite it either way.
Well, this is the perfect way of rewriting it. But in terms of discussing what terms are, you need to understand that you need to change the subtraction to addition in your mind.
So I believe it was that the 3x minus 7 that you used?
Okay, 3x minus 7, what about it?
I believe that's the one you used, and you
Okay.
said that was actually
Because you can write 3x minus 7 as 3x plus a negative 7.
So even though there's nothing there,
What do you mean nothing there?
in other words, it's just understood.
What's understood?
Like a parentheses is understood that you multiply, so, you know what I mean? Like if it's
No.
if it's 3 in parentheses and there's a 2 after it, you understood saying that you multiply the
3 times 2.
and there's no actual
That's
sign.
right.
So when you see this, you're supposed to understand that you insert the positive.
Yes, 3x means 3 times x.
Right. So is that similar? I'm just trying to associate.
No,
it,
that's
so
not.
it all-
No.
so I'm just
Okay.
trying to memorize it.
Yeah, so what I need for you to do is did you buy your book?
This one.
Okay, so I need to show you what chapter I need for you to focus on, okay?
Okay.
See me after class, I'll tell you what chapter to look at.
Okay.
All right, we can combine like terms. All right, so they're like terms, we can combine them. So for example, we talked about constants. So let's do this example. 3 plus 5, those are like terms. They're constants. You all know what 3 plus 5 is. What's 3 plus 5? 8. So in the previous section, when we used the distributive property, there were instances where we added the numbers. So those were constants, because we can add numbers. Three x plus x. Those are like terms, right? So when they're like terms, all I do is add their coefficients. So basically, we're just adding their coefficients. So with this coefficient I'm pointing to is what?
3x.
This coefficient is, no, someone said 3x. Coefficient is what?
I'm sorry.
3. What's this coefficient? 3 plus 1 is 4. So therefore, 3x plus another x is 4x. All right, 7x minus 2x. That's 5x. Now that's easy to do because you all know from many, many years ago that 7 subtract 2 is what? 5. So that's 5x. All right, now what if you had this? 2x minus 10x. Negative 8x. All right, so that's the same thing as saying 2x plus a what? Negative 10x. And so last semester, and again, if you don't remember these rules from last semester, you have access to a calculator. I'm adding two numbers whose signs are different. So you subtract their absolute value. 2 from 10 is what? 8. Then the rule continues and it says you take the sign of the one that has a larger absolute value. Well, negative 10 has a larger absolute value, and what's that sign? Negative. So that's negative 8x. All right, now 5, suppose you had 6x squared minus 10x squared. What do you think that is? Or first of all, are those like terms?
Yes.
Yes, so I can combine them. You're basically looking at the coefficients. I'm pointing to the first term. What's that coefficient? 6. I'm pointing to the second term. What's that coefficient? Nope. Negative 10. Okay? Because the term is not 10x squared. What's that term? Negative 10x squared. So what's the coefficient? Negative 10. So those of you that said 10 makes you understand that coefficient is a negative 10. Negative 4x squared. So that's combining like terms. All right, so this is on page 607, number 16. All right, so here's number 16. You have this expression, c, subtract 7c, plus 2c. c, subtract 7c, plus 2c. Now, some of you can look at this and indicate right away what the answer is. So what do you think the answer is? Negative 4c. Now, in your mind, remember, first of all, how many terms do you have here? 3. Are any alike? Yes, in fact, they are all alike. And all you're basically doing with like terms is adding, I'm using the word adding, their coefficients. So in other words, I'm saying this coefficient is what? 1. Plus this coefficient is what? -7. Plus this coefficient is what? 2. And then remember, just add from left to right. Now again, you don't have to write this part down, but in your mind, that's what you're doing. What's 1 and a -7? And what's the -6 plus 2? -4. So therefore, C minus 7C plus 2C is a -4C. Okay? Number 18. All right, you have 6G, that's a G, plus 5, minus 3G, minus 7. All right, so let's talk about that one. How many terms are there? 4. Are all of them alike? No. So I'm going to point to the first term, 6G. I'm going to ask you, is this term, can I combine it with any other term? -3G. So I'm going to, now you don't have to do this, but I'm just going to do this. I'm going to put one little line underneath like this just to indicate that those are like terms. So when we combine like terms, we add their coefficients. So in your mind, you're saying this coefficient is what? 6. I'm going to add that to this coefficient, which is what? And what's 6 and a -3? +3, right? So what's 6G subtract 3G then? 3G. So far my answer is 3G. So when I combine those two terms, I have 3G. All right. Now, what are those other two terms called? Constants. So I can combine constants. This constant is what? Plus this constant is what? What do I get when I combine them? So how do you write this? 3G minus 2. All right, so there's your answer. 3G minus 2. Okay? So when you did that worksheet yesterday, some of you were trying to combine them when they weren't like terms. So now you know what like terms are. Okay? So that's 18. Let's look at 24. 24 you can use your calculator with because it has decimals in it. So use your calculator.
Can we get our sheet for corrections in
Say it again.
I said, can we come up and get our sheet back?
No. Those are just worksheets. You have plenty of worksheets and plenty to drop. You just got to know it for the test, though. All right, 7.9y minus 0.7 minus y plus 0.2. So 7.9y minus 0.7 minus y plus 0.2. All right. So let's use the calculations. Those are decimals. Yeah, in fact, you really need a calculator for that part, right? So first of all, let's underline the like terms. 7.9y, I can combine it with what? You said y. You should have said what? -y. All right. Now, what's the coefficient of that first one?
7.9.
And then you're adding a what?
-1y.
-1. The coefficient, though, is just -1. And what do I get when I combine those? No, not -6.9. 6.9. All right, so you're saying on your calculator, you're saying 7.9 subtract 1, right? Or 7.9 plus a -1. What goes in the blank, though?
6.9y.
6.9y. So that's what I have so far. Now, the other two terms are called constants. Now, those are a little bit harder to do in your head, so use your calculator. So on your calculator, now remember this, I'm putting an arrow here. So there's these two terms that have arrow pointing to are like terms because they're constants. What's that term right here, though? -0.7 plus, and then what's this term? All right, so on your calculator, you're going to say negative 0.7 plus 0.2 or 0.2. What do you get? Negative 0.5. So you can write this as minus 0.5. Okay?
I used my calculator the other day and I had no idea.
Do you have to write the 0 in there?
You can do 0.5. Just make sure I can see that decimal. So if I can't see the decimal, I think you mean a 5.
Okay.
So sometimes we put the 0 in front to kind of emphasize that decimal. Okay, 30. All right, 30, you have 8h plus 13h minus 6 plus 7h minus h. So 8h plus 13h minus 6 plus 7h minus h. How many terms do you see? 5 terms. Is that correct? 5 terms. How many of them are alike? 4. So I'm going to underline the 4 terms that are alike. 8h, what's the other one? What's the next one? The next one. Negative h. And so basically you're just adding our coefficients. So your calculator, just say 8 plus what? 13 plus what? Plus what? Negative 1 equal 27? All right, so what's the answer? Minus 6. Because that negative 6 is the only constant, correct? All right, so there's your answer. Now, what some of you are trying to do in that worksheet was at some point, because you really didn't understand like terms, now you do, you're saying this was 21h. It's not 21h. It would be 21h if that was a what right here? A 6h. Right. So now you know that those are not like terms. That's all you can do with it. Leave it alone.
You gotta know how to stop something.
That's right. All right, 36 has decimals in it, so use your calculator. 36. All right, 36, you have 0.4y, that's a y, minus 6.7 plus y, minus 0.3, minus 2.6y. All right, let's start with the y's. First of all, how many terms do you see? 5. How many terms are alike that contain the y? 3. Okay, so I'm going to list the coefficients. So here's the first one. What's this coefficient? Okay, 0.4 plus plus 1, right? You agree? Okay. Plus, and then what's this one? Negative 2.6. So in your calculator, 0.4 plus 1 plus the negative 2.6, what you'll get? Say it again?
Negative
Negative 1.2.
Negative 1.2? All right. So in the blank, though, you're gonna write it as what? Negative 1.2y. Okay. All right. Now those other 2 terms are called what? Constants. So this constant that I'm pointing to is what constant? Good. This other constant is what? Negative 0.3 or negative 0.3. Add, put that in your calculator. What do you get?
7.
What kind of 7? It's not 7. Negative 7, right? It's negative 7. So therefore the answer is negative 1.2y what? Minus 7. Okay. All right, now let's look at this example. All right. You have negative 5, 6x plus 3x minus 2. Negative 5, 6x plus 3x minus 2. So there are 3 terms. Which two are like?
Negative 5, 6, and then
So negative 5, 6x and 3x. All right, so let's talk about the coefficient. What's this coefficient right here? I'm going to add it to this coefficient, which is what? Positive 3. All right, so you have access to a calculator. Let's just use a calculator now. And then for some of you, I need to go back and remind you how to add fractions or subtract fractions with unlike denominators, because some of you still struggle with that. So even though you have access to a calculator, it will help you in college algebra to know how to do this by hand as well. Understand how to do this rather than relying too much on the calculator. The calculator will hurt you at some point if that's all you do. All right, so first of all, let's use a calculator. So you remember how we did this on your calculator? What do we do?
negative sign.
Negative 5 divided by 6. Oops. 6, and then what? Plus 3, and then what do I press? Equal. All right, so I get this decimal. You know you don't leave it as a decimal. The problem had fractions in it, you leave it as a fraction. How do I change this decimal to a fraction? Remember what to do? Second PRB equal sign. And so what is this written as though? What's that called? A mixed number. Mixed number. So that's 2 and what? 1 6. So this is 2 and 1 6. Let's go back and rewrite as a improper fraction. So remember how to change a mixed number to improper? 6 times 2 is 12 plus 1 is 13. All right. So this right here then will be 13 over 6 what? X, and then what? Minus 2. All right, so 13 over 6x minus 2. All right, let's do this by hand though. So we're going to do this by hand. So this was using a calculator. By hand, I have negative 5, 6 plus 3. Now I'm going to write 3 as 3 divided by 1. All right, now remember, some of you were adding numerators and you were adding denominators together. That's not what you do. When adding, subtracting fractions, you have to have the same partition, same denominator. So what's the smallest? Always use the least. You can use any common denominator. I can use 12, I can use 18, it doesn't matter. But always use the least. It makes things a lot simpler. What's the smallest number that 6 and 1 will go into evenly? 6. So I'm going to write two fractions with 6 as the denominator. And so I'm going from negative 5, 6 to a fraction that has 6 in the denominator. I'm going from 3 over 1 to a fraction that has 6 in the denominator. Those are called equivalent fractions. Equivalent fractions. This one's easy because this is 6 and this is 6. So if the denominators are the same, then what else must be true? Numerators have to be the same. So negative 5, 6 is equivalent to itself. Now I want to go from a 1 to a 6. In order to get this to be a 6, I got to multiply this by what? 6. But what I do to the denominator, I have to do to the numerator. 3 times 6 is, and it kind of makes sense that 3 is the same thing as 18 divided by 6. Because what's 18 divided by 6? 3. So now can I add the fractions? Yes. So basically all you do is keep the denominator and you add the numerators. What's a negative 5 plus 18? 13. And that's what we had here. Okay? All right, so remember, when using the calculator, though, it's going to put it as a mixed number. Remember, this is called a mixed number. I don't know if you wrote it down, but that's called a mixed number. This right here is called a what? Improper fraction. So those are words you had last semester. It's one of the chapters in that book.
It's easier for me to write it out by hand.
That's fine. No, I mean, knowing how to do it by hand is going to help you in college algebra a lot more than the calculator.
I just question myself when I do on my calculator, like, how do I know it's right? I don't know.
That's why you,
Then I have to recheck it on by hand anyway.
you know. Yeah, I mean, you could enter something wrong in the calculator, and you'd be surprised when the answer should be, let's say, 3, and someone puts 3 million. Because they're relying too much on the calculator without really understanding it. So the calculator can hurt you. Don't rely too much on it. Make sure you know how to do by hand as well. All right. And remember, going from here to here was called equivalent fractions. Just want to make, we've talked about the word before, just want to make sure you know the word again. Equivalent fractions. So in other words, 3/1 is equivalent to what? 18/6, that's what I mean. -5/6 is equivalent to what? -5/6. Okay, let's look at 46. All right, 46. Now 46 is going to use what you turned in today. You can see what I mean by that. And then it's also going to use what we just did. All right, here's 46. You have something that looks like this. That's a 9. No, yeah, I mean, my Q's look like a 9. I understand. That's a 9. That's a Z. Okay, so what do you think you're going to do first? Distributive property. All right, so you use the distributive property. All right, distributive property. So it looks very similar to what you turned in. So 9 times Z is 9Z. And then 9 times 7 is 63, and then minus 15. Now you can combine like terms. In fact, the terms that are like here are called what terms? Constants. So use your calculator. What's 63 minus 15? 48. So what's the answer? What would you put in the blank?
9Z plus 48.
All right, that's what you put in the blank. All right. So the directions will say something like simplify. Let me make sure that's what the direction says before I. That's usually what it's going to say. Huh?
The math lab is full already.
Say it again.
The math lab,
What about it?
I said they're full, the lab, well, I thought it would be today, but I did, it's full of questions.
How? I've never assigned it. How can you have it?
The math
That's
lab,
section 8.7. I didn't assign.
I'm talking about the distributive property.
Yeah, that's from 8.6.
Right.
Yeah, that has some distributive property in it. All right, so let me just quickly find out what that direction says. Page 607. All right, so the directions will say something like, this is number 46, it'll say simplify. It'll say simplify the expression. All right, so simplifying that part means, first of all, you have to use what property? Distributive property, and then you combine like terms. So distributive property, then do what? Combine like terms. Now the idea is gonna come back because in a near section, probably like next week or so, you're going to be solving equations. And those equations, when you have parentheses, you're going to be to use a distributive property. You're going to be combining like terms again. All right. So once you use a distributive property, the next idea is possibly to combine like terms if you can. All right. Okay. So that's 46. All right, let's look at 48. 48. All right, here's 48. You have this expression. Now remember, all these are called expressions, right? Don't confuse that with an equation. An equation has what in it? An equal sign. So if it doesn't have an equal sign, it's called a what? Expression. And I think that's one of the questions in my math lab. All right, so you want to simplify this expression. You see parentheses. When you see parentheses, first thing you need to do is what? Distributive property. Okay, distributive property. So everything that's inside the parentheses, you're going to multiply by what? -3. And again, it helps if you draw these arrows. You don't have to. But you got to know your signs. You have to know that a negative times a positive is a negative. A negative times a negative is a positive. What's -3 times 2z? I'm sorry, 2x. Negative 6x. What's negative 3 times a positive 5?
Negative 15.
And then plus what? Okay, so that's where I'm at, right? Okay. So I use the distributive property. The next step is to combine like terms. Are any of those like terms? This one and this one. What's a negative 6x and a positive 6x? 0. 0.
So if it's 0x or
Nope. You don't even write it. You don't even put anything. It's just 0. Now, it is technically 0x, but 0 times x is 0. Anything times 0 is 0. So in other words, the only term left is what? Negative 15. So don't say 0x minus 15, because I need you to understand that 0x just means what?
Nothing.
0. 0, which we don't write. All right. All right. Let's look at this example. Write this example. All right. Suppose you had negative 1. Now this part's a review from the previous lesson. Let's just see if you remember this. All right, so let's simplify this expression. So simplify. How would you simplify this?
Negative 1 times
But what property are you using? Tell me the property. Distributive property. So negative 1 times 2x is negative 2x. Negative 1 times a negative 3, because that's what that term is. Positive 3. I use distributive property. Next step is to combine like terms. There aren't any like terms, so you're done. That's what you had to turn in. Okay? Now remember, let's kind of review this one. What if you had this? What if you had that? You had one like this on your worksheet that you turned in today. What you see this that's in front, what is that understood to be? Negative 1. So basically what you did was you rewrote this as negative 1 times 3x plus 4, right? And then you did what? Distribute. So what's the answer?
negative 3x minus 4.
Yep. They're not like terms, so you're done, correct? All right. What if you had this? All right. Write this down. That's the expression. Okay, so you're going to, first of all, get rid of the parentheses using what property? Okay, so that means everything inside the parentheses will multiply by what? All right, so remember, that right here is understood to be negative 1, right? So you can distribute. Negative 2x, and then what? Plus 3, good. And then write everything else over. All right, so I just wrote everything else over. Now what do I do? Combine like terms. All right, let's start with the x's. What's a negative 2x, and what do I add it to? Positive 4x. What does that give me? No, not negative 2x. Positive 2x, right? Make sure you see that. A negative 2 and a positive 4 is a positive 2. And then what about your constants? Plus 3 minus 1, which is? Plus 2. Okay? All right. Let's look at 50. 50. Here's what you have. All right. Just write it out first. So you have this expression. In all the problems we've done before this one, before number 50, there are how many parentheses? 1. So you use the distributive property how many times? Before you used it once. Here, how many parentheses do you see? 2. You use the distributive property how many times? Twice. So in this first parentheses, I'm going to multiply everything in there by a 2. In the second parentheses, I'm going to multiply everything in there by a negative 1. So let's do that. 12x minus 2 minus x plus 7. Good. So now that kind of looks like this previous example. Okay? So I use the distributive property twice. Now what we're going to do? Combine like terms. Let's put the x's first.
So 11x?
Y'all agree? 12 subtract 1
11x.
is 11. So 11x. Now what about the constant? This constant here is a what? This constant is a, what's, yeah, -2 plus 7 is 5, right? So what's going to be my answer?
11x plus 5.
Very good. Okay. All right, so let's see where we're at. Let's see. All right, we're not done, but let me give you some worksheets at this point.